Hello, everybody. Good morning. Today we're about to start a workshop, our first workshop of the day. So we have Didrik Rokhaug from Nordic, who is an application engineer in the tech support group over at Nordic Semiconductor, who's going to give a workshop on building a power-efficient mobile weather station with a Thingy 91. And the cool thing about this one is that Nordic is actually giving away 3 of the Thingy 91 modules, which are a really cool little all-in-one IoT module. If you're here, you'll probably already know about it, but you'll see it soon. It's a self-contained, battery-powered, programmable module for IoT that you can do all kinds of cool stuff with. I'll let Didrik tell you more about that. Didrik has a Master of Science degree in Cybernetics and Robotics from the Norwegian Institute of Science and Technology. So cool. He's been working as an application engineer in the tech support group at Nordic for 3 years, focusing on the NRF 91 series and the NRF Connect SDK. In his free time, he enjoys hiking and is also learning to play the guitar. Good morning, Didrik. How's it going?
Hello, it's fine.
I'll turn it over to you. Take it away.
Thank you. Hello and welcome, everyone. I'm going to show you how to build a power-efficient mobile weather station with the Thingy 91, as Alex said. And this summit is about sustainability, and one of the reasons why we need to monitor the weather is that it has some agricultural uses. If you know if it's dry or raining, you can also know how much water to use or not use, which is important. And here in Norway, where it's cold and we need indoor heating, it's also nice to know if it's the temperature outside, so you know if you need to heat the building more or you can heat the building less. But before we get started with showing how to build it, I wanted to run a quick poll to get an impression of the audience. Looks like most people are at least somewhat familiar with Nordic and our products. So we have a decent amount that's not familiar at all. And many who haven't tried our development kits at all. So I'll try to keep that in mind when I go through the workshop. But most people are familiar with the Visual Studio Code, which we will be using, which is good. Okay. So we will be using the Nordic Thingy 91. It's a prototyping platform for our NRF 91 SIP. The NRF 91 is a system in package which supports LTM, NB-IoT, and GNSS, so positioning. And what we mean by a prototyping platform is that it supports, it has a lot of onboard sensors and also a battery, which makes it easy to, when you're developing, to use it as a quick prototype before you have your own PCB. For actual development, we recommend to use one of our development kits, which has an onboard debugger and easier access to the pins, but it does not have the sensors, so you need to add those yourself. The Thingy 91 also has an nRF52 BLE system on chip, which we use as a UART to USB bridge because the nRF 9160 does not have a USB itself. And like I said, the Thingy has a lot of sensors, including temperature and humidity, air quality, and air pressure, which also comes in really handy when we're going to build a weather station. And we're going to build it on LWM2M. And there's a reason for that. And a lot of the cloud protocols or protocols used to communicate with cloud platforms are TCP based. TCP has more overhead than UDP, and it is also not very nice to work with on networks with higher latency, such as NB-IoT. Because of the guaranteed delivery and the repeats in TCP that can cause problems. So LWM2M is built on UDP, so we avoid those problems. It's also built on CoAP, which is called, or is short for Constrained Application Protocol, which also similar to UDP has low overhead. And CoAP is, the way I like to think about it is that it's an optimized HTTP. So it's similar in that it's a request response type protocol, but the application has a lot more control over what is happening. If you want to have acknowledgements of the request and response being received, or if you just want to send a request, hope that it gets there, maybe get a response. LWM2M also has predefined data models. So when we send data, we don't need to say how the data is encoded. We just say that we have a temperature sensor and here's the temperature. We don't need to specify all of this ourselves. It's also secure by design, which is really important. We don't want all of our IoT devices to be hacked. And it has device management built in. That's what LWM2M is primarily for. So when it comes to bootstrapping and onboarding our devices to the cloud, when it comes to updating the devices, all of that is handled by the protocol. So during this workshop, I'm going to use an NRF 9160DK, as we can see here on this slide, as an external programmer. That's just going to make it easier to actually program the Thingy91. The Thingy91 also has a bootloader on it, so you can load new applications on the Thingy91 without an external programmer. It's just going to make it a lot easier. I'm going to end the slideshow. So we'll be using the Visual Studio Code editor, which is what we are using as for our NRF Connect SDK. And we have our own plugin for it, which we can see if we can find here. So if you download this extension pack, you will get pretty much everything you need. We also have a desktop application called NRF Connect for Desktop. And in it, we have a toolchain manager application. And here you can install the NRF Connect SDK with a single button press. And it should work on all platforms. So we're going to use the newest version of the SDK, the version 2.1, which I already have installed. There, just moving the. So in the VS Code with the NRF Connect for VS Code extension, you'll have this welcome page or panel. Then I moved it over to the right side just to make it easier. And we're going to start with creating a new application. And the first question you get is if you want a freestanding or workspace application. The workspace application comes with its own installation of the NRF Connect SDK. Yes, I can provide a link later. Just seeing one of the questions there. Which is great if you have your own fork of the SDK, if you need to make some changes. And it's also a nice way to tie the application to a version of the SDK. But I'm going to choose a freestanding one here. It requires that you have the SDK already installed, so you can have one centralized installation and then multiple applications. And like I said, we're going to use the version 2.1. And use the corresponding toolchain. we're going to base it on one of the applications. And by pressing the browse button, you get this nice overview. There you see all the samples in the SDK and the documentation. So we can search for LWM2M and select the LWM2M client sample for the NRF9160. Hit select, and we can give it a name, for instance, weather station, and press create application. Will then give you all the files that you need and that are part of the sample. And you'll also see down here in the applications tab, we have the weather station application. So to build it, we simply click build here to add the build configuration. We're going to build it for the Thingy 91. And in this workshop, we're going to use the AV system LWM2M server. And we already have an overlay config for that. So what that means is that we have our project configuration, which has a lot of options. We can also add more. In this case, we need to add the URL of the server. So we can add that one as an kconfig fragment. And if you have NB-IoT coverage in your area, you can also, or you must also select an overlay for NB-IoT. Otherwise, the sample will use LWM2M. Like I said, LWM2M has security built in via DTLS and using PSKs. The credentials should, of course, be kept secret, so I've added another file with my secret key. Otherwise, the default key is in the kconfig file, and you can see the default key here. So we could, if we want to change this, we can add the config to the project.conf file and set another key. We can then press build configuration. And if we double press on the building, then we can see the progress. Takes a bit of time, especially the first time. If we were to change some of the source files, it will just need to build those source files and then link it again. But if you change the configuration, it will need to build it all. What we can do in the meantime is to go to AV system, and you need to create an account. They have a free tier, which we are going to use. So here I've already logged in. Then we can press add a device. The first time you create a device, it will give you this one automatically, or the first time you create an account and log in. You need to add the endpoint name, which is the name of the device. For the LWM2M client sample, it will have this prefix, URN:IMEI:, and then the IMEI of the device. For the Thingy 91, it's printed on a little label. Yeah. We can also give it a name that's human readable. For instance, weather station. And then we need to add the key. And the NRF9160 modem uses keys which are written in hexadecimal. So we need to check this one. Then I'll move the window out and copy my key in. And press add device. And for some reason it didn't like it. So let me just try again. There we go. So it will then wait here until the device is connecting. And we can see here that sample is finished building. The VS Code extension will detect connected development kits, but it will not detect thingies. But because we're using the development kit as a programmer, you can just go ahead and press flash. And there the device has been programmed, so it will connect to the network and then try to connect to the server. There we see the device connected successfully. We can press next. And here we see that the server already has figured out what capabilities the Thingy91 has. Like I said, LWM2M is built around device management, so that includes discovery of capabilities. We can keep on going to the summary. And then we get to this page for the device. Where we see, for instance, it's connected to the cellular network. The signal strength is not great, but okay. I'm on the Telenor network here in Norway. We can go to data model and we can see the data. So for instance, the pressure is a bit less than 1 atmosphere. Then we can see the temperature, which is nice and comfortable. And for instance, the Thingy91 has a button, so we can add observations to these values. Because if I just press the button now, nothing will happen on the server. But we can read it. So the counter will count how many times I press the button. And then the next time the device is connected to the server, you will see that I pressed the button twice. But we can also add an observation where it will automatically, the device automatically will send the value to the server. For instance, if the value changes by at least 1. So now if I press the button, we should see that the number automatically updates. And already we kind of have everything we need for a weather station. But it's not, we want it to be mobile. And we want it to be sustainable. And for that, we need it to actually not use a lot of power. If it uses a lot of power, then it either needs to be connected, which makes it not mobile, or we need to charge it, or if it's not replaceable batteries, then we would have to throw them away, which is even worse. So we can measure the power of the thingy. And to be able to do that, we need to modify the Thingy91 slightly. It has a header for current measurement, but the header itself isn't soldered on, so we need to solder it, and it's also shorted by a solder bridge. But by cutting the solder bridge and soldering on the header, we can use the Nordic Power Profiler Kit 2. as a current measurement ampere meter. And I have that setup going. And again, with the in NRF Connect for Desktop, we have an application for the power profiler kit. So by using that application and selecting the PPK I have, you can also use the PPK as a power source, but I'm going to use it as a ampere meter. And it allows you to select the sample rate and for how long. And the more higher sample rate we want, the less we are going to be able to sample for. But 10,000 samples per second is more than enough, and we can extend this duration for way longer than the workshop. So we will be good. And then we will see the current profile of the thingy going. And as you can see, it's now listening for pages from the network, or messages from the network fairly often, which uses a lot of power. And here we can see that it's sent an update to the server, just saying that it was here. And then it needs to be in an even more power consumptive mode for a little bit. And if we let this go for a little while to see how long what the average current is. For instance, between two updates to the server, we can stop the live view so it doesn't move. It's still capturing the current profile, we just don't see it. We see that we get an average current of 4.23 milliamperes, which is quite high. And I found this handy battery life calculator from Didrik. And if we enter the 4.23, here we see that it lasts for almost 2 weeks, which is a while, but we can do better. So the first thing we can do is that LWM2M has something called queue mode, where it will, rather than sending things all the time directly to the server, it will queue them up and then send a whole bunch of messages at one time. We can combine that with the cellular IoT feature called power saving mode, where we will turn off the radio for a duration. Now there's an overlay configuration file for that as well. So we can add it by going over here and select edit build configuration. And then we add another kconfig fragment. This one is called overlay q.conf. Then we can build again. And because we changed the configuration, it has to rebuild everything because it's not able to know what we can or what source files are affected by the configuration changes we have made. Maybe while it builds, we can see if there's any questions. I see there is one asking if we sell hardware debuggers or if something like a Segger J-Link will work. And we don't sell hardware debuggers, but our development kits come with an onboard debugger. So that debugger is what I'm using here, or you can use Sega J-Links. Okay, and when it finished building, we can flash it again. And if we then look at the current profile while it's flashing, we can see here that it's flashing, which consumes a bit of power. And then we see the application rebooting. Connecting to the network. And talks to the server. And so far, the current profile looks very similar to what we have over here. The big difference now is that we are using power saving modes. So after talking, we need to be active listening on the radio for a little while to see if there's any incoming messages. And after that, we can turn off the radio. Which should happen very soon. Here we see the radio turning off, and we now consume much less power. There is, however, one thing that's a bit strange here for someone who knows how power saving mode works. Like I said, here we talk to the server, and then we need to stay in this mode called RSC connected mode, where we are in an active connection with the cellular tower for a little bit. Then we need to stay in RSC idle for a while to see if there's any incoming messages. But then we see that we talk to the server again, or we send something. And if we look at the logs on how the application works, here it disconnects from the server because we will be offline for a while. And cellular network have NAT layer or network address translation layers and firewalls with states. We cannot be sure that our IP address and port will be the same the next time we try to send. And DTLS uses IP address and port to know who we are. So the next time we send, the connection will not work. So we need to connect to the server again, doing a new DTLS handshake. But doing it before we go to sleep is a bit wasteful. And there is another keyconfig option we can add, which is called, all the options start with config. And because we are using our extension, we will get autocomplete suggestions. And I don't know which keyword language I'm using. There is a option called LWM RD client suspend socket at idle. And if you know what it's called, then you can just go into the project configuration file and add it yourself. If you don't know, you can press the kconfig button. And kconfig really is a menu of configuration options. So here you can see all the options and their values. So for instance, if we start to search for LWM2M, we can find all the LWM2M related options. And this is a great way to see, go exploring and finding other options and finding what the library can do and not do. Including we can turn on TLS session caching, which will make the TLS handshake go faster the next time we connect. And we can also search for a socket to help us find. Here we see the option we want. We can press the information button to also get the documentation for it. And we can save here to have the changes we made saved to the build folder, or we can save to file to have it saved to our project configuration file. Again, we need to build, but if we just press flash button, it should detect automatically that we have made changes and rebuild everything again. So if we look at the power consumption, again, we see we can measure from, and that's our alarm. And just go turn it off really fast. Sorry about that. It's getting late here in Norway, so the burglar alarm turned off. What I was saying is that we can measure the current from we connected to the server to the next time connect to the server. We see now we have an average current of 2 milliamps, which is about half of what we had. If we go back to the battery life calculator, we will see that we now get 3 weeks or almost 4 weeks. But it should now have finished flashing as well. So if we go back and watch live, we again see the same profile where we program the device, it connects to the network and then connects to the server. And now what we should see is that instead of sending to the server again, it should just go straight into power save mode and using much less current. Which is what we get. And if we just look at the connection event, from we start to search for the network until we go to sleep, before it took 1 minute and 21 seconds. but now it takes just 52 seconds, which is a lot better. And I see someone asking if this is with the sensors running. They are, but I don't remember exactly how often we check the values of the sensors. But this is with the sensors connected and all that. So also, as we have seen, it's the radio which is the main consumer of power. So what we want is to have the device offline for as long as possible. So it takes a little while until it connects back to the server again. But it should happen fairly soon. Another question I see in the chat is if there is a way to attach external devices to Thingy 91 GPIOs. And the answer there is a bit more complicated. It has some pins which are connected to the transistors, so you can drive external devices. Other than that, you have to use some of the test pads which are available and connected to the SPI and I2C buses already used for the existing sensors. Just zoom out a bit. And here we see the device connecting to the server again. So if we look at the current row from we first connected to the server until the second time we connect to the server, we now get an average current of 1.7 milliamperes, which if we plug it into the calculator, it will now last for more than 4 weeks. And there is one final step that we can make to have it consume even less power, and that is to turn off the UART. If we see now the average current while the radio is off, it's over 500 microamperes, which is a bit high. That is because we have the UART running, which requires that we have the clock running as well. But we can disable it by adding config serial equals no. And to make it work, we also have to turn off the shell feature in the sample. We can again hit flash, and it will go and take some time. So I guess we can do some Q&A while we wait.
Sure. I think we had a couple of questions come into the Q&A earlier. Something about if my country doesn't support LTE or NB IoT, may I use it for GPRS data?
The NRF 9160 does not support 2G, fortunately.
Okay. If LWM2M is a constraint protocol, how can it handle OTA as it's slow and FW images are big in size?
So it's not necessarily slow, and you would use either CoAP or HTTP for actually downloading the image. I haven't done any throughput testing on CoAP versus HTTP, but they shouldn't be too different. And like I said, you can use HTTP itself. So.
Gotcha. Okay. Is the server free to use?
Yes, it has a free tier. There's also paid tiers, but it has a free tier with 10 devices, I think.
Okay, great. Could you show the connection setup with Nordic device and power profiler?
My desk is a bit messy, but I can see if we can manage. Is there a way I can see my own camera for this? There we go. So this is what it looks like. You can see the PPK here. She's connected to the Thingy 91, and I have soldered on the header there. You also see the connection to the DK I have. See if I can.
We're actually up on our time here. Is there anything left of the demo that we haven't gotten to? Because I want to make sure you can finish your demo.
The only thing is to see if we get it work without the UART, but it looks like I forgot something to turn off. We can try to turn off logging again, but it will take some minutes.
Okay.
What we should have seen at least is current draw of under 10 microamperes, which would help. So when I did some testing earlier, we should have an average current of less than 1 milliampere over the long time.
Great. Well, we are up on our time, so we are going to move on to our next session, which is going to be over in the lobby that you can find. Thank you, Didrik, so much for going through this demo. It's been awesome to watch, and we appreciate you joining us. I just typed that support desk in the chat, so make sure you copy and paste that over, and we'll see you at the next session. Thanks, everyone.
Great.